Thank you very much for your company. Welcome to your channel, Transmission Lines Engineering TV. We are in the last video before entering the technical topics about transmission lines, design and such. I'd like to reiterate my thanks for your patience before getting into the technical topics. I have spent all this time in watching the previous videos to provide the tools that could help you to establish the organization of the activities prior to the engineering development of other disciplines. In my opinion, before starting the engineering work, I prefer to invest a good time in the planning of the engineering process, the identifications of the documentations to be developed, the way in which I will store this information, and how the engineering area will interact with other disciplines, and finally how engineering will support in the conformation of the documentation, which is not calculations or drawings but merely administrative documentation, but very important. Now, getting into the subject matter, understanding electricity is not easy, especially because it is invisible. It doesn't smell, it doesn't have a flavor, and the worst part is that it is very picky because it doesn't like to be touched. So if we dare to touch it, it gets angry, and if it gets too angry, well, we better have a wheel mate. Similarly, it's not like touching a pipeline, which we can see it, we can smell it, and we can realize if there's something inside. And the best part of the case is that it's not as special as electricity, because it allows to touch it. And if we dare to touch it, she will not get as angry as electricity. And if it gets too angry, as the highest we could only burn, but just if it is a high pressure pipeline. So in short, it's easier to understand a mechanical system rather than an electrical system. So in this video we will see how does a transmission line, electrically speaking, work. Surely you have heard the terms of voltage, current, resistance, watts. All these electrical terms are perfectly understandable for a designer with an electric background. But let's remember that not all designers have an electric background or electric skills. Many are civils, structurals, are technologists, or simply don't have any of this background and don't have an understanding of how these terms relate with the operation of a transmission line. That's what this video is all about. Make these terms understandable to any person with any background in a clear and easy way, in which will help them to have a better vision when designing a transmission line, and either be by manual or software such as PLSCAD, for example. In order to understand it better, we will make the analogy with a transmission line and a pipeline. So let's get started. And first, we will make the analogy between the terms. So the first one, voltage in kVs is going to be equal to the pressure in the pipeline in kilograms per square meter. The amperes or amps will be equal to the flow in the pipe in gallons per second. Watts will be equal to the product to be transported by the pipeline in gallons. The resistance in a transmission line will be equal to the friction coefficient in the pipeline. The grounding system will be equal to the exceedance drainage system, and the grounding resistivity will be equal to the exceedance drainage system's capacity. Now, transmitting and receiving substations will be equal to the emitting and receiving pumping stations. The electric losses will be equal to the product loss to the friction in the pipeline. Now we have a transmission line connected by substations on both sides. A substation, which is the emitting pumping station, and a receiving substation, which will be the receiving pumping station. As number 3, the conductor cables of the transmission lines are going to be represented by the main pipeline. Number 4, the shield wire, which is the line grounding system, which will be represented by the excess drainage system. Number 5, the grounding resistivity system in each structure is going to be represented by the exceedance drainage system capacity, that is, the speed to maintain the main flow at a stable level. Number 6 is the conductor electric resistance, which is represented by the pipe friction coefficient, which will oppose to the free flow of the pipeline. Number 7, the amount of energy to be transmitted in watts is equivalent to the amount of oil product which will be transported throughout the pipeline. Number 8, amperes or amps, is the watts flow which will be transmitted in a time unit, which means watts per second, and it is equivalent to the flow transmitted in the pipeline in gallons per second. Number 9, the volts, which is the electric force with which the amount of watts which will be transmitted from one substation to another, and it's the same as the force or pressure required in the pipeline to transport the oil amount in gallons from one station to the other in kilograms per square meter. Number 10, electrical losses or watts losses due to the cable's resistance are represented by the gallons lost in the pipeline due to the friction. With this have seen graphically the analogy between the transmission line components and a pipeline. Now we can see how they work together. So number 1, the emitting substation will send to the receiving substation an X amount of watts, or at least that's the intention. The emitting pumping station will send X amount of oil gallons to the receiving pumping station. Now, why do I mention the phrase "at least that's the intention"? So, number 2, when the watts flow through the conductor wires, they will do so at certain speed in watts per second, which is the same as amps or amperes, and the gallons will flow in the pipeline at certain speed in gallons per second, which is equal to a flow. Number 3, it turns out that the conductor cable is not a perfect conductor and has certain resistance against the watts flow. In a pipeline, the friction coefficient of the material is the one which will oppose us to the gallons flow. Number 4, since the cable resistance is an obstacle to the watts flow, Not all these watts will manage to get through the cable, as some will get stuck in the road, and in this way reducing the amount of watts reaching the receiving substation. In a pipeline, the pipe friction will cause not all the gallons to reach the other side. This is called a transmission losses or transportation loss. Because of this reason, the cables must have a resistance low enough so that the losses are minimal, and the pipeline must have a low friction coefficient or a smoothed internal surfaces to have less losses. These losses are something inevitable and will always exist. This is the reason I mentioned the phrase, "at least that's the intention." Number 5, in order to overcome the cable's resistance and maintain an acceptable speed of the watts on the cables, it is necessary to push the watts with enough force so that they reach the other side. That is, they need a high voltage in kilovolts, capable of giving them enough thrust to complete the journey. And in the pipeline, we need to push the gallons with a pressure in kilograms per square meter or thrust, such as they have enough strength to reach the receiving pumping station. As number 6, it happens that sometimes are circumstances in which the transmission line is overloaded by means of an atmospheric discharge or operation of switches in the substations, causing additional currents in amperes higher than normally transmitted. This can cause the cables to overheat to the point of a mechanical failure. The same happens with a pipeline. When there is additional flows to those normally transported, and the consequence might be that the pipeline explodes or is damaged because of the flow capacity is exceeded. This is a phenomenon not acceptable neither in transmission lines nor in the pipelines or in any other infrastructure. So, in a vehicular bridge, it is similar to the amount of traffic that can withstand before collapses. This is avoided by means of the grounding system in the transmission line, and this is the functionality of the shield wire to connect all the structures to ground and provide the overload multiple evacuation points. In the case of the pipeline, the exceedances drainage system in different points is the one which will allow the overpressure to escape. Number 7, finally, the grounding system on the structures is a very important component, almost more important than the rest of the design, and it is the one which is less paid attention, or we take it as the easiest one. The shield wire connects all the structures together, creating an electrical grounding supernode. You might have heard this concept of supernode for those who studied electrical circuit analysis at some time. But what happens if at each evacuation point you have a high resistivity in ohms greater than the acceptable? The answer is simple. That evacuation point is closed, is clogged. Now imagine what could happen if several evacuation points are clogged, or several structures have a high resistivity. The overloads will be trapped in the shield wires, and it will not be able to exit, and since they cannot go out from the shield wire, the overloads will try to find another way to get out. And what's the place? The conductor cable. And therefore, the phase to ground faults, that's when it happens, or phase-to-phase or three-phase failures causing the line go out from service. And now imagine if it is a 400 or a 500 kV line. So we better have a good amount of candles at home, because that's why the massive blackouts happens, like the one in 1965 in northern zone of the United States and Canada. Or even a simpler example, the grounding system of something as complex as a transmission line can be compared with a simple kitchen utensil, a pressure pot, as simple as that. I hope that this video has given you a better overview, a better understanding about the electrical operation of a transmission line. Sorry to insist, but I think that it is important that every transmission line designer, regardless of their education background, must have the idea and the obligation to know these concepts, to keep them in mind when developing the different designs documents for their transmission lines. May this information be useful for you. Believe me, that's my best wish. Thank you for watching this video. Thanks a lot for your visiting. Don't forget to subscribe and leave your comments. So until next one, Transmission Lines Engineering TV, training to power the world.